Okay, so we're going to talk a little bit about radical equations here. And just to remind you, what we want is to isolate the radical, or whatever is raised to the rational power, and then undo that radical by like squaring or cubing or whatever both sides of the equation, or by raising to the reciprocal power, which is actually the same thing. So let's look at A. It says take a square root of x squared plus 1. That's equal to x minus 3. So we're going to square both sides of this because the radical is already isolated. That should give me x squared plus 1, technically absolute value, but I'm going to leave that for now, equals x squared minus 6x plus 9. Remember that this is x minus 3 times x minus 3, so you have to make sure to distribute that, otherwise you're getting, you're going to just square it and say, oh, it's just x squared minus 9 or something. That's not true. Now if we solve this, we could subtract the x squared from both sides, gone, and we get 1 equals negative 6x plus 9. That means that negative 8 is equal to negative 6. So negative 8 over negative 6 equals x. So x equals 4/3. So we must check our answers when we're solving radical equations, because we might get extraneous solutions. We might get solutions that just don't work. And that's because of this weird squaring to square root business. Sometimes there's absolute value and it just messes everything up. So let's plug it in to check. You must check. Square root of 4/3 squared plus 1. Does it equal, question mark, 4 over 3 minus 3? That's our question. I can tell you right now, this is not looking good. Square root of 4/3 squared, that's 16 ninths, because we're squaring the top, squaring the bottom. Does it equal 4/3 minus 3 times 3 is 9, 9/3? Why is this not going to work? Because this is going to be negative, that's going to be positive. So this is not going to work, I already know, but let's follow it through. 1 is 9 ninths, so this is 25 ninths. Does the square root of 25 ninths equal negative 5/3? The answer is no, because this is positive and this is negative. So this is extraneous, meaning there is no solution. Or the solution is that there's no solution. So you can see that it's really important to check. Basically what we're showing is that this graph never crosses this one. Okay, let's see. Maybe we could try B here. Plus 1 all raised to the 3/4 power equals 8. So this is already isolated. So let's raise both sides to the reciprocal power and see what we get. Okay. When you raise something to the reciprocal power, you're multiplying the powers, so you just get 2m plus 1 to the 1 equals 8 to the 4/3. So now we need to simplify this, remembering that 8 to the 4/3 is the cubed root of 8 to the 4th power. That's 2 to the 4th power. 2 to the 4th power is 16. So m equals 15 halves, or 7.5, aka 7.5. Okay, now let's check. Is 2 times 7.5 plus 1 all to the 3/4 power equal to, question mark, 8? Well, this would be 16, because that's 15 plus 1, to the 3/4 power. Is it equal to 8? That's the 4th root of 16 cubed. That's 2 cubed. Does it equal 8? Yes. So that is your solution. There's one solution. Is that true that there's one solution? Or should there be more than one? I think there's only one solution there. So I will let you think about some of these other questions, but that should give you a sense of how you solve these equations and how you check your answers to make sure that they are not extraneous.